All right, everybody, I'm going to get started here. And one of the things that I wanted to remind everybody of is that if you don't have your own graphing calculator, because I'm going to use GoGuardian and Google Meets when you're testing, you can use the Rapid Identity TI-84 graphing calculator. So what you're going to want to do, and for today as well, because we're going to use the graphing calculator today, is go to your Rapid Identity, sign yourself in, and then this weird little square up here that's made up of little rectangles, you're going to hit that, and we want Applications. And then if you just hit grades 9 through 12, you'll be able to scroll over till you get to the T's. And there it is, TI-84 Plus Calculator app. And yours will load up automatically. Mine, because I have a teacher's account, does this weird stuff here because I'm not allowed to have it on my Schoology and on my computer at the same time. But that definitely have a tab open with that today as we're going through this stuff. And I want to start again today with something that will also be talked about in the review. I already made the lesson video for your practice test for tomorrow. So you'll have a practice test, and then in the Schoology updates you'll have a review assignment, and also in the Schoology submissions for homework you're going to see the homework assignment in there too. But that's tomorrow. We'll talk about that a little later. So with this one, don't write down all the blah, 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 but like we've done the last couple of days where I just had you grab a piece of notebook paper and write these down. Maybe you still have some space on that. Just write down f of x equals -3 times the quantity x minus 7 squared plus 2. Because all of these things that it says up here, we're going to be filling in the blanks for anyway. So it says without graphing, name the vertex, axis of symmetry, the maximum or minimum value, the domain and range, and the transformation of the function when compared to the parent function f of x equals x squared. So I look at this and I think it has those parentheses squared. That's vertex form. So if it's vertex form, I probably better start by saying where the vertex is. So somebody unmute and tell us, oh, you know what? I wonder if you can see that really well, because that sometimes is the blind spot, isn't it? So maybe if I move that down a little bit, that'll help. So can somebody unmute and give us the vertex for that little baby?
7, 2.
It is 7, 2. So what's the axis of symmetry?
7.
X equals 7. Yeah, x equals. Don't forget that little piece because it has to be an equation for a line. Now, I know they said without graphing, but you want a sketch of it. Whether or not you make the sketch on the paper or you do it in your head, I don't care. But what you need to know is, because this has a -3 in the front, it's going to open down. And that's, like I said, the only little picture you need in your head. And I'm not going to take points off if you make that little sketch as you're working through this problem. Because we know that spot right there is 7, 2. And that's going to help you get the rest of these little blanks filled. So you want to write down axis of symmetry, x equals 7. Vertex, the ordered pair, 7, 2. Now with just that little sketch, does this have a maximum or does it have a minimum?
A max.
And what is the highest value that it reaches?
7.
Oh, not the x though. Remember high. Yeah, because it's the y values. So it's going to be a 2. What's the domain of all the parabolas we've been talking about recently? Yes, all real numbers. But now that we know where that max is, what can we put for the range?
Y is less than or equal to 2.
Perfect. If 2 is the highest y that we get to, then our graph is 2 and everything below it. So y is less than or equal to 2. Now, transformations. So put another transformations colon, I guess, on there. Because we haven't talked about this for a while. I mean, it's, boy, before Thanksgiving when we were talking about this. And the transformations, remember, we do left to right. So from left to right, the first thing we're going to hit is the negative. So somebody tell me what the negative is responsible for.
If it opens up or down.
Yes, that's what we do to get our little sketch here. As a transformation, we have to use a little bit fancier language than that. So as a transformation, what is that negative doing to the graph? Tell me how it goes from opening up to opening down. What's the transformation that makes that happen?
Flipping over the x-axis.
Exactly. So reflect over the x-axis. Just talked about the negative. We didn't say anything about the 3, so we have to talk about the 3. What's the 3 responsible for in transformations?
The stretch or the...
You're right, vertical stretch. Vertical stretch, factor of 3. Now take a look in the parentheses. Remember that x is the naughty one. So x minus 7 is telling us to do what?
Seven to the right.
Yes. Translate 7 units to the right. And, because we're not done, what's this plus 2? Yes, up 2 units. There it is. So definitely going to be a problem asking you about all of this good stuff and reminding us of the transformations. Now, the transformations, that's not how we graph them. You know, I've spent the last 2 days going over that with you again, how we graph these. But we do still have to remember what A, H, and K stand for. So this is a good problem to have on any of the tests where we've had some graphing on there. All right, and like I said, the practice test, Fridays are the days where we just do digital learning again, because that gives teachers like me time to write all your fabulous tests and all that kind of stuff that I have to do. And so I made a video of the first half of the practice test already. And once you're done with that, there's a review assignment that you need to do. So I think I'll just put that at the end of the video. I didn't yesterday, but I think I'll add to it and put the assignment at the end of the video too, so everybody knows what that is. Now, back to our objective from yesterday, which is solve quadratic equations by factoring and solve quadratic equations by graphing. So we did a lot of factoring, and we haven't touched the other part of the objective, which is by graphing. Now it turns out that all the problems that we're going to see, we can do them by factoring anyway, but in the future we're going to have some where, hey, we have to use a graphing calculator to find them, because when we are solving by factoring, we are only seeing what are called the rational zeros. And rational zeros means it's something you can write as a fraction. So it's a nice number. Sometimes we get zeros that are like the square root of 2 and the negative square root of 2, and they're just ugly. And so we may use a calculator to figure out what that number is instead of trying to figure it out because it can't factor. So we're going to solve a quadratic equation by graphing. And it says, what are the solutions of the quadratic equation? Again, if we see solve or solutions, we need to think, zeros. I have to find the zeros. So for this one, it's not ready to go. It's got stuff on both sides. So we would go ahead and subtract 2 from both sides and add 2x to both sides and get 5x squared plus 32x plus 12. Now, they told us we're supposed to do this by graphing. So 5x squared plus 32x plus 12 has to go into the graphing calculator, and we're going to go ahead and put it into y sub 1. And then, like it says, we're going to graph and we're going to calculate those zeros. Now, I didn't want you to have to wait for me while I punch all this in because it usually takes longer with this one. So I put mine in as y sub 2. It's the only graph you're going to see because it's the only one that I have the equals highlighted on. So when we graph it, that'll be it. So go ahead and punch in 5x squared plus 32x plus 12 if you haven't already. And then let's hit zoom 6. Hey, it's hitting the x-axis in 2 spots. Here and here. So my job is to figure out where that is. Now, maybe sometimes we get lucky, and maybe if we hit second graph, we'll see a 0 in the table. So what I'm looking for is, where does y equal 0? Oh, there's one, -6, 0. But as I go in the other direction, I see the y's are just getting higher and higher and higher. So far, I know that it's -6, 0. I'm going to go back to my graph. And yeah, it looks like this other one has to be some kind of little fraction or something in there to get me that 0. Now, the good news is Blinky can find these for us. So let's say I didn't go to the table first. What Blinky is going to ask me is, are you to the left of the intersection and are you to the right of the intersection? So for this side, we're going to have to be above it to be to the left and below it to be to the right. And that's because we read these graphs off from left to right. But when we get to the other one, it's going to be backwards because below it is going to be left and above it is going to be right. Let me change the color on that. And we have to find each one of these separately. So I have to remember that Blinky is asleep in there under second trace. Now, look at number 2. It says 0. Blinky can find the zeros for us. So we hit number 2. And where's Blinky? Blinky's way up at 0, 12. I'm looking at what it says in the red letters here. Blinky's lost. So I'm going to hit my left arrow. There's Blinky. And get Blinky back over here because I like to do the left one first and then the right one. And what I'm doing is I'm watching the y value to see when it becomes positive again. So Blinky's starting to come back up. All right, there's Blinky. So now I need Blinky to be above the x-axis, and the calculator doesn't know the language above and below. All it knows is left and right. So somewhere above it is to the left, and I hit enter. And then I use my right arrow to go below it. Anywhere below it is to the right of it, and hit enter through guess. And Blinky tells me it's a perfect -6, 0, which is what I saw in the table anyway. It's the other one that I'm really interested in because that one wasn't in the table. So second trace, number 2. And now I need to move Blinky in position for that one. And again, I'm watching those y values. Blinky's starting to come back up. Okay, good. Now I can see Blinky. So Blinky is below the x-axis and to the left. I hit enter. I use my right arrow to go above the x-axis, and I hit enter, and I hit enter through guess. And that turns out to be a negative 0.4. So, without having to factor it, I was able to figure out that the two zeros for this one are negative 60 and negative 0.40. So what I need you to do, so that you don't forget how to punch all this in, is we're going to make a little sketch in your notes here. So let's make a little Cartesian coordinate plane. And our parabola did something like that. And what I need you to do, because this is what people send me emails about, is mark this as, hey, this would be left and this would be right on that side of the parabola. And on the other side of the parabola, left is below it and right is above it. Because if you don't have those in the right places, when you hit enter after guess, you're going to get a message from Blinky that says there was no sign change. Error. There was no sign change. So over here, left is above, right is below, and over here, left is below and right is above. And that's how we find those. So there are two zeros. Now, here's another really important thing that we need to know, and that is this one could have been factored. And I know that because I see the zeros that just came out of here. And I realize that negative 0.4, that's negative 4/10, which reduces to negative 2/5. So my zeros, looking their best, would be negative 60 and negative 2/5. Now yesterday we went through and found a lot of zeros, and all of them were either nice integers like our negative 6 or little fractions like negative 2/5. So that means this one was factorable. I could have done it without the graphing calculator. And I can kind of use an educated cheat to figure out what it must have been. Since this was negative 6, that must have been x plus 6. So now I think, okay, since this was a 5 and this is only an x, this must have been 5x. And if this is just a 6 and I need it to be a positive 12, that must have been a 2. So 5x squared plus 2x plus 30x is 32x. 6 times 2 is 12. There it is. So we could have done this one by factoring. Now, in yesterday's homework, there was a problem that you could not solve by factoring. And it's going to be pretty obvious to me who just copied the answers down when I look at it, because you're going to have a decimal in there. Only one person sent me an email or asked me yesterday, what's going on with this problem? I could not find them. So if you couldn't find them, you should have written down, cannot be factored. And if I see the answer just sitting there with no work behind it, that's going to mean you just copied the answer down. So don't do that. Use what we've been talking about in class and give these things a try. Of course, after today, now you can go back and do that problem because I just showed you how to use the calculator. Alrighty, so we have to get this one ready for the calculator. Oh, that's probably the blind spot. There we go. Is that set to go? Should we just punch it right in? If not, what do I need to do?
Move the 4 minus x to the other side.
Sounds good. I like to keep my x squareds positive, so that'll keep that positive. So we have 4x squared minus 13x plus 3 equals 0. Where do we put that into the calculator? What button do we push? Okay, guys, everybody has their icon on. I can't see you. So I don't know if you've already punched this in and you already have the answers or whatever. So please answer my questions and stick with me, and then I'll know you're getting this. Where do we put this into the calculator?
The y.
Yeah. So y equals, and like I said, I already put mine in so you guys didn't have to wait for me. But I'm just going to turn that one on. 4x squared minus 13x plus 3. Now, how do I get to see the parabola? What should I hit? If you want to see the graph, what buttons should you push?
Graph.
You can hit graph. We already had our Zoom 6 in there. Oh, cool. Kind of looks like maybe 3, 0 is a perfect one. Let me check the table. Second graph. Yep, 3, 0. It's all about the zeros and the y. The other one didn't look quite so perfect. So, how do I wake up Blinky?
Second and track.
Second trace. Which one of those is going to find us what we want?
2.
Yes. So, this is the one I need. Up here would be to the left, and down here would be to the right. So I can hit enter right now. Blinky was in a pretty good spot. Right arrow, below it, enter, enter through guess, 0.250. Wait a second. Was this one factorable? 0.25, that's 25 1/100ths. That reduces to 1/4. So can we factor that polynomial?
Yes.
Yep. We wouldn't have had to graph this one. We did, but we wouldn't have had to. Oh shoot, what were they again? 3, 0 and 0.250. So, working backwards, we'd say, well, I'm going to start with the 3, 0 because that one would be easiest. This must have been x minus 3. Well, then the other one, x times something had to be 4x squared, so that would be 4x. And then negative 3 times something has to give me positive 3. That would have had to be a negative 1. And yeah, we would still get the same zeros. Now that's not true for some of the problems that you have in the homework. They are not nice zeros. It's not something you're going to look at and go, oh yeah, I know that fraction. I know exactly what that is. So if it says to use the graphing calculator, just go ahead and use the graphing calculator. Now, we haven't covered word problems yet from this section, so of course we have to do that. And problem 4 says, using a quadratic equation, from the time Mark Twain wrote The Celebrated Jumping Frog of Calaveras County in 1965, frog jumping competitions have been growing in popularity. The graph shows a function modeling the height of one frog's jump, where x is the distance in feet from the jump start. So here's the frog. And this problem, every year I get to it, just totally freaks me out. This frog makes this jump, and the equation is y equals negative 0.029x squared plus 0.59x. Here's why it freaks me out. Imagine walking down a trail in Elk River, And all of a sudden, you get smacked on the side of the head by a frog. I don't want that happening. Yuck! Frogs are slimy. So, I would really want to know this stuff. If we're talking about a frog that's like a super jumper, can they smack me in the side of the head? So they're asking us how far the frog jumped, and then we're going to have to figure out how high the frog can jump. Says, let's graph this and let's find the zeros. Now, I'm going to flat out tell you that just like the other problems that we did, you would not have to graph this one to solve it, because this can be factored. So I could just take an x out and then find the zeros. So this one pretty obviously is 0, because if the frog hasn't jumped yet, time is 0. It hasn't gone anywhere, so it's jumping 0 feet. This one is going to give us our answer. So with this one, we'd subtract 0.59 from both sides and divide by negative 0.029. And for most people, that's probably going to get you the answer faster than the graphing calculator. But I'm going to show you both ways. So if you take the negative 0.59 and divide it by negative 0.029, we get, where is it, 20.34 feet. So you wouldn't have to use the graphing calculator. But let's do it so we can take a peek and see what all this frog jumping is about, as I'm hoping not to get splatted in the face by a frog. All right, y equals, so this is the one I need everybody to punch in, negative 0.029x squared plus 0.59x. Now, a frog can't jump a negative amount, so it's kind of silly for us to have negatives, but maybe we just hit zoom 6 to start with, just to see what it looks like. So this is actually where the frog is starting their jump. Now that's disturbing. Here's why. Notice the frog, after an x value of 10, is still in the air. Oh boy. So what I need to do is add more x's to see when the frog comes down. So I think I'll take that to 30. Since 10 looked to be about halfway, and I'll go a little bit more. Okay, so here's this frog's jump. Starting at 0, then the frog jumps and hits the ground again. And what we wanted to know was, how far is that? So we need to find this 0 right here, which means I'm going to need the left to be here and the right to be here. Second trace, number 2. Hey, Blinky found a good spot this time. So somewhere above the x-axis, you hit enter. Now the reason I'm getting closer is because Blinky actually does calculus when we hit this button. And the farther Blinky is away from that spot, the more math Blinky has to do. But you could actually hit it anywhere above the x-axis. Now I'm below, enter through guess. There it is. The exact same answer we would have gotten by hand, 20.34. So it's going to work that way on the test as well. And it would probably be better to just show your work and do the algebra way than to grab the graphing calculator. But you could always check. You know, you'll have time to double check that. So that's how far the froggy was jumping. Now we want to know, how high did the frog jump? Well, we just got to see the frog jump. And here's what we know. How high is explained by the vertex. So again, I wouldn't need to use the calculator to do this one. it's in standard form, so I could use x equals negative b over 2a. Notice there's no c because there's not a number hanging out in back here. But this would be negative 0.59 divided by 2 times negative 0.029. And that will give you, I did this one this morning so that we could see all of these numbers are the same with the graph, 10.17. But that's the x value, that's not the y. And if we want to know how high the frog is jumping, well, then we're going to have to put that back into the original. So our y value is going to come from negative 0.029 times that 10.17 squared plus 0.59 times 10.17. It's just putting it back into this equation. And it turns out that that y value is a 3. So this frog can jump to a height of 3 feet. It's not going to hit me in the face. Could hit me in the leg as I'm taking my walk, but it's not going to hit me in the face because the height was 3. So how high did it jump? About 3 feet. And then this one says, well, if you are going to put this into the calculator, the hardest part for people is usually figuring out what should we use for a domain and range? What should we use for our x's and our y's? Well, given that we just solved the problem and we know that it can jump to 20.34 feet, it would probably be reasonable to have our x values be from 0 to maybe 25. That would be a good domain. We could see the curve that way. Our range, well, we just found out it can jump as high as 3 feet. So our y values, maybe we go 0 to 5. And we can see the curve. And mostly what this does is it reminds us that you cannot use negatives for all of this. So the best window for this graph, like I said, maybe 0 to 30, 0 to 5. Shows what's really happening, that the frog is on the ground, it's jumping, and then it's coming back to the ground. But to find the zeros, we usually want to have a few of those negatives down here so that Blinky can be above it and below it. So usually we'll put a couple of negatives on there anyway. So again, I'm showing you both ways. If you're saying right now, Cedar Home, I've never been comfortable with the graphing calculator, you wouldn't have to use the graphing calculator for this test because we had formulas like x equals negative b over 2a and f of negative b over 2a to get all that information for us. But it certainly would be a good check. So now we've got a kicked soccer ball. The function y equals negative 0.03x squared plus 1.60x models the path of a kicked soccer ball. Well, yeah, kicked soccer balls tend to look like that. The height y is the distance, and we've got x, the units are in meters this time. How far does the soccer ball travel? How high does the soccer ball go? Describe a reasonable domain and range for the function. Well, if we want to know how far, that's finding the zero. So I take a look at it. To decide if I have to use my graphing calculator or if I can use algebra. And just like the last problem, I realized, well, I could just factor an x out of that, and I don't need to use the graphing calculator. So now, this makes sense, because if you haven't kicked the soccer ball, it's not going to go anywhere. And this one is where I'm going to find the other zero. So we'd subtract 1.60 from both sides. And then we'd divide by negative 0.03. And for this one, we would get, oh, it works out. This one is perfect. It's 53 1/3 meters. When you punch it in, you see 53.3333 repeating for that one. So 53 1/3 meters is the answer to how far did it travel. And then, if I want to figure out how high the soccer ball went, that's about the vertex. And again, just like the last one, I don't have to find that with the graphing calculator if I don't want to, because I can use x equals negative b over 2a and f of negative b over 2a. But I do want to show you how you could find it with the graphing calculator. So we put this one in, and while I'm changing things here, you can go ahead and punch that one in. That's the negative 0.03 x squared plus 1.60 x. This time we're just going to let the calculator find that vertex for us. So the part we have to do some thinking about is the window, because we don't know how strong this person is, and we have to remember what x and y stood for. So the distance is x, and this is in meters. Well, I don't know, I suppose if they're a really good soccer player, maybe, this is probably a stretch, 100 meters. And then the height, well, again, that depends on, where are they trying to get it, because sometimes you need to kick the ball really high and let it hang up in the air, but sometimes you're just going for distance. So maybe I'll try 25 for that one. So there it is. Oh, and there's that green that's hard to see. Now, what I really want Blinky to tell me is where that is, right up there, where that vertex is. And I notice that's a maximum. Wait a second, I thought I saw that word earlier when we were doing graphing. Second trace, look at that, number 4 says maximum. Well, let's hit that. So now Blinky's asking me to be the left of the maximum. Well, I'm not on the left side of this mountain. I got to go over to the left side of the mountain. So there's the left side of the mountain, anywhere over there, and I press enter. And then I need to move anywhere to the right, because Blinky asked me to find the right bound. So after you're coming down the right side of the mountain, you hit enter, and then you can hit enter through guess. 26.666666, so 26 2/3. And the y value is 21.33333, so 21 1/3. And you have to recognize they were asking about the height, and the height is about the y values. So our answer would be 21 1/3 meters. Again, you wouldn't have to use the graphing calculator to get this if you didn't want to. You could do negative b over 2a, plug it back in, and find what you needed. But it sure is really nice to have the graphing calculator to double check. Did I do that math right? When I found that vertex, that maximum, did I find it in the right spot? Now, if we go back, we see that not only does it do maximum, it'll also do minimum. So if we need to know where the lowest spot is on a parabola, we could use number 3 instead. So our objective today was to find the zeros using the graphing calculator. We did that so we could use that to check our math that we did with factoring. And then for the word problems, because of the way these were set up, we actually could just do them by finding the zeros using algebra and factoring. We wouldn't necessarily have to use the calculator if we didn't want to. But here's what I usually find. There's probably about 10 people in class that are saying, I like using the calculator. I can find those buttons and everything's really great. And then there are those that are like, I kind of struggle with it. I don't have my own calculator. It's hard to do. Well, know that for this test at least, you could do all of this with just algebra. So you wouldn't have to do anything with that graphing calculator other than using it for adding and subtracting and multiplying and dividing. So there is, yeah.
For the practice test, would you show us how to do both ways on the practice test or just one of them?
I think on the practice test that I recorded last night, I think I just did it algebraically.
Okay.
Since it's not a requirement, for this one, we just did those algebraically. Okay? So give it a try if you're feeling good with it. After you've solved them. And that's mostly because on the test, usually people want to show steps in case they mess up somewhere, and I can give them partial credit for it. If you just use the graphing calculator and you write down the wrong answer, then I can't give you any partial credit. So most people feel a lot safer doing this algebraically. All right, everybody. So 4-5 day 2, page 229. We have 27 to 32, number 36, 48 to 50, and 60. Feel free to hang around and work on some and ask questions if you get stuck. All that good stuff.
Is the test next week Monday or Tuesday?
It is Tuesday.